Hi, I'm Catriona, a third-year PhD student in Regenerative Medicine at the University of Manchester. In this video, I'm going to give you a brief introduction to stem cells. So stem cells have two key properties. Firstly, they have the capacity to self-renew, meaning they can make new copies of themselves. Secondly, they are unspecialised cells that are able to differentiate. This means that they can turn into other cell types. For example, they could become skin cells, liver cells, brain cells, and blood cells. There are three main types of stem cells: embryonic stem cells, adult stem cells, and induced pluripotent stem cells. We'll talk about each of these in turn. So embryonic stem cells, firstly, unsurprisingly, are derived from embryos. After the sperm fertilises the egg, a zygote is formed, and this then begins to develop into an embryo. At around day 5 post-fertilisation, the blastocyst forms. Within this is the inner cell mass, and this is a source of embryonic stem cells. Adult stem cells, on the other hand, are populations of stem cells we have all throughout our bodies, particularly in places where there is a high turnover of cells, such as the skin. Their role is to replace dying and damaged cells. Bone marrow and fat tissue are sources of mesenchymal stem cells. These are my favourite cells, and I'm investigating whether they could be a therapy for stroke. Last, but by no means least, induced pluripotent stem cells can be generated by taking adult cells and reprogramming these back to pluripotency using a combination of proteins known as Yamanaka factors. This was a monumental breakthrough in the field of regenerative medicine and led to Japanese scientist Dr. Yamanaka being awarded a share of the 2012 Nobel Prize in Physiology or Medicine. To finish up, let's go through a couple of definitions. Cells within a really early stage embryo are totipotent, meaning they can give rise to all the cell types. Embryonic stem cells, on the other hand, are described as pluripotent, meaning they can give rise to several cell types, but not all cell types. Lastly, stem cells which are described as multipotent can differentiate into some cell types, but are a bit more limited than pluripotent stem cells. My beloved mesenchymal stem cells, for example, can become fat, cartilage, and bone cells.